December 24, 1943. Aberdeen Proving Ground, Maryland. Artillery officers gathered around what looked like a suicide mission, disguised as a weapons test. Two infantry section engineers, Kroger and William Muser, were about to fire a 57mm cannon that vented its explosive blast backwards through the crew. "You're going to kill yourselves," the artillery observer warned. The engineers ignored him and pulled the trigger anyway. The weapon had no recoil. None. Zero. The shell screamed 450 yards downrange and obliterated its target with cannon-level precision. But the real shock wasn't the hit. It was what didn't happen. No broken shoulders from recoil. No crew knocked unconscious. No weapon jumping off its mount. American paratroopers had been dying because they couldn't carry real artillery into battle. Bazookas maxed out at 150 yards. German machine gun nests sat safely at 300 to 400 yards, picking off advancing infantry like targets in a shooting gallery. The Army desperately needed pocket artillery, something paratroopers could carry that hit with the power of a cannon. Everyone said it was impossible. Artillery section was spending millions developing a massive 105mm cannon based on captured German designs. Proven technology, safe technology, then two engineers with a freelance research project proved that the most dangerous-sounding idea was exactly what desperate times demanded. The morning air at Aberdeen Proving Ground carried the familiar scent of cordite and metal, but something felt different on December 24, 1943. Artillery officers huddled in their observation bunker, field glasses trained on two men who seemed determined to commit professional suicide. Kroger knelt behind what looked like a conventional 57mm cannon, except for the perforated metal cylinder attached to the breech. His partner, William Muser, made final adjustments to the weapon they called the T-15, though most ordnance experts preferred the nickname Kroger Muser, a combination of their surnames that sounded more like a medical condition than a breakthrough weapon. "Those infantry engineers are about to learn why we don't reinvent artillery," muttered Colonel James Harrison, Aberdeen's chief artillery evaluator. He'd seen too many promising weapons programs end in disaster, and this contraption violated every principle of cannon design he'd learned in 30 years of service. The British concept they were attempting, venting explosive gases backwards through hundreds of tiny holes in specially designed cartridge cases, struck him as elaborate engineering suicide. Kroger felt the weight of institutional skepticism pressing down like a physical force. But the numbers in his field notebook told a different story. American paratroopers were dying in Italy and the Pacific because they couldn't carry effective artillery into battle. The bazooka, lauded as revolutionary just 2 years earlier, had revealed fatal limitations. Its unguided rockets lost accuracy beyond 150 yards, and German machine gun positions routinely set up at 300 to 400 yards, safely beyond American infantry weapons range. Mortar crews could lob shells that distance, but mortars required indirect fire with forward observers, making them useless for the precise, immediate fire support that paratroopers needed when they hit the ground behind enemy lines. The problem had become a tactical nightmare. During the Sicily campaign in July, entire companies of the 82nd Airborne had been pinned down for hours by single German machine gun nests, positioned just beyond bazooka range. Artillery support meant calling in massive bombardments that took 30 minutes to coordinate and announced American positions to every enemy unit within miles. By the time shells arrived, German crews had either relocated or reinforced their positions. What paratroopers needed was pocket artillery, something a two-man team could carry, set up quickly, and fire with rifle-like precision at targets that were currently untouchable. The artillery section had their solution already funded and in development. Their T-19, a massive 105mm recoilless rifle based on captured German Jarrett 40 designs, used proven blowout plug technology. When fired, the plugs at the weapon's rear would rupture in a controlled manner, venting gases backwards to eliminate recoil. German engineers had already solved the technical problems. American contractors just needed to copy their work and scale up production. The T-19 would give infantry units devastating firepower, assuming they could somehow transport a weapon that weighed over 200 pounds and required a dedicated crew of 4 men. But Kroger and Muser had been working on a different approach in their spare time, pursuing what their superiors dismissively called freelance research. Instead of German blowout plugs, they were attempting to perfect a British concept developed by designer Dennis Tone Burney. Their cartridge cases featured exactly 400 tiny holes drilled through the side walls, then lined with plastic to prevent gas leakage until the moment of firing. When the propellant exploded, pressure would rupture the plastic lining simultaneously, venting most of the blast backwards through the holes while still providing enough forward pressure to propel the shell at 12,200 feet per second, 4 times faster than a bazooka rocket. The concept sounded suicidal to anyone who understood artillery. Conventional wisdom held that venting explosive gases near the crew was as dangerous to friendlies as to the enemy, as one Aberdeen report bluntly stated. The backblast danger zone extended 50 feet behind the weapon, meaning crews would need to clear substantial areas before firing, hardly practical for infantry in close combat. Most ordnance experts predicted the weapon would either fail to generate sufficient muzzle velocity or kill its own crew with misdirected, explosive force. Muser double-checked the shell's pre-engraved driving bands one final time. These copper bands, machined to exact specifications, would grip the rifle barrel's grooves and spin the projectile for accuracy while reducing friction that normally created recoil. Every component had to work perfectly. There were no second chances when you were experimenting with controlled explosions near human beings. The high-explosive shell weighed 5.3 pounds and carried enough explosive to demolish a concrete bunker, assuming it could reach the target with cannon-level precision. "Fire when ready," Kroger called out, his voice steady despite knowing that hundreds of careers depended on the next few seconds. If the T-15 worked, it would revolutionize infantry support. If it failed catastrophically, 2 promising engineering careers would end in court-martial proceedings, assuming they survived the test. The trigger squeeze felt like any other artillery piece, smooth, deliberate, inevitable. The explosion that followed defied every artillery officer's understanding of physics. Instead of the bone-jarring recoil that normally accompanied 57mm cannon fire, the weapon remained perfectly stable. Gas pressure vented backwards through 400 precisely drilled holes with a sound like a controlled steam explosion, while the shell screamed downrange at 1,200 feet per second. 450 yards away, the target bunker disintegrated in a cloud of concrete dust and twisted metal. Direct hit. Perfect accuracy. 0 recoil. Colonel Harrison lowered his field glasses and stared at the T-15 in stunned silence. The weapon had just delivered artillery-level destruction, with the portability and precision that paratroopers desperately needed. At 44.4 pounds, the T-15 weighed less than a single bazooka rocket crate. Yet it could engage targets at 3 times the bazooka's effective range, with devastating accuracy. The implications were staggering. Infantry units could finally carry weapons that matched their tactical requirements instead of being limited by what conventional wisdom deemed safe. But as smoke cleared from the test range, everyone present understood that proving a concept worked was only the beginning. Converting a successful prototype into a combat weapon would require overcoming institutional resistance that ran deeper than mere technical skepticism. The artillery section had millions of dollars invested in their German-inspired solution, and admitting that 2 infantry engineers had found a better approach would require a level of bureaucratic humility that rarely existed in wartime procurement decisions. Kroger and Muser began collecting their equipment, knowing that the real battle was just beginning. By November 1943, the T-15 had survived enough preliminary tests to earn official scrutiny, and that scrutiny arrived in the form of a side-by-side comparison that would determine which recoilless rifle program received full production funding. The artillery section's T-19, their 105mm behemoth based on German Girat 40 technology, rolled onto Aberdeen's main testing range with the confidence of proven engineering. Behind it, a crew wheeled the T-15 into position like David approaching Goliath, except this David carried a weapon that most observers still considered an elaborate way to commit suicide. Colonel Harrison supervised the test with the methodical precision of a man whose recommendations would determine how American infantry fought for the remainder of the war. The T-19 represented everything the artillery section valued: incremental improvement of proven German technology, substantial funding from established defense contractors, and a design philosophy that prioritized crew safety over portability. At 214 pounds, it required a 4-man crew and specialized transport. But it delivered devastating firepower with blowout plug technology the German engineers had already perfected in combat. The first test measured raw destructive capability. The T-19's 105mm high explosive shell obliterated its target bunker with satisfying finality, creating a crater that could swallow a small automobile. Observers nodded approvingly. This was the kind of overwhelming firepower that won battles decisively. When the T-15's turn came, its 57mm shells seemed almost delicate by comparison, but the target bunker disappeared just as completely, reduced to scattered concrete fragments and twisted reinforcing steel. Adequate destruction, Harrison noted in his evaluation sheet, though privately he wondered if adequate was sufficient when American lives depended on stopping German strong points with single shots. The T-15's smaller warhead carried 250 grams of explosive compared to the T-19's massive payload, but both weapons had achieved the mission objective of bunker elimination. The question wasn't whether the T-15 could destroy targets. It was whether infantry units needed maximum destruction or maximum portability. Accuracy tests revealed the first significant advantage of Kroger and Muser's approach. The T-15's rifled barrel and pre-engraved driving bands delivered consistent 3-inch groupings at 400 yards, performance that matched dedicated anti-tank guns. The T-19's smooth-bore and blowout plug system produced acceptable accuracy for area targets, but lacked the precision required for engaging specific windows, gunports, or personnel in fortified positions. Paratroopers fighting in close quarters needed surgical strikes, not area bombardment, but the mobility comparison exposed the fundamental difference between artillery section thinking and infantry section innovation. The T-19 required its 4-man crew plus specialized wheeled carriage, making rapid deployment impossible in broken terrain or contested landing zones. Setup time averaged 12 minutes from arrival to first shot, assuming the crew could find level ground and establish clear fields of fire. The T-15 could be carried by 2 men, assembled in under 3 minutes and fired from shoulder, bipod, or improvised rest, depending on tactical requirements. Kroger watched Harrison's expression carefully as the numbers accumulated on the evaluation sheets. Weight, 44.4 pounds versus 214 pounds. Setup time, 3 minutes versus 12 minutes. Crew requirements, 2 men versus 4 men. Effective range, 450 yards for both weapons. Armor penetration, 3 inches for the T-15 versus 4 inches for the T-19. Ammunition weight, 5.3 pounds per T-15 shell versus 11 pounds per T-19 round, the mathematics of infantry. Warfare were shifting in favor of the smaller weapon, but institutional momentum had its own mathematical principles. The breakthrough moment came during rapid-fire tests. Artillery doctrine emphasized deliberate aimed fire with careful target selection and ammunition conservation, but infantry combat often demanded immediate suppression of multiple targets with whatever firepower was immediately available. The T-15 could engage 6 targets in the time required for the T-19 to service 2, and its lighter ammunition allowed crews to carry enough rounds for extended engagements without resupply. Muser had spent weeks perfecting the perforated cartridge case design, working with plastic manufacturers to develop linings that would rupture uniformly under explosive pressure while maintaining structural integrity during transport and handling. Each case required exactly 400 holes drilled to precise dimensions and positioned according to gas flow calculations that balanced forward projectile velocity against backward venting requirements. The plastic lining had to be thick enough to prevent gas leakage during storage, but thin enough to rupture completely when fired, ensuring that no partially vented cases would create dangerous pressure. Variations. The engineering elegance impressed even skeptical ordnance experts, but elegance didn't overcome institutional resistance. Reports began circulating that described the T-15 as dangerous to the crew as to the enemy, focusing on backblast hazards rather than combat effectiveness. The 50-foot danger zone behind the weapon became a talking point for critics who argued that infantry units couldn't safely employ recoilless rifles in close combat situations where clearing rear areas was impossible. Training requirements became another source of controversy. The T-19's German-inspired design operated similarly to conventional artillery, requiring minimal additional crew education. The T-15's backblast characteristics demanded new tactical procedures, crew positioning protocols, and safety awareness that went beyond traditional infantry weapons training. Conservative military planners viewed additional training requirements as unnecessary, complications that would delay combat deployment, and increase the likelihood of operator errors under stress. But battlefield reports from Italy were shifting the tactical conversation in ways that bureaucratic resistance couldn't ignore. The September landings at Salerno had demonstrated exactly why paratroopers needed portable artillery support. German defenders had positioned machine gun nests and anti-tank guns at ranges that neutralized American bazookas, while remaining immune to mortar fire without forward observers. Entire battalions had been pinned down for hours by weapons that could have been eliminated quickly, with accurate long-range direct fire. Division commanders began requesting immediate deployment of any recoilless rifle that could give their infantry the firepower advantage they needed. The T-19's superior destructive capability meant nothing if it couldn't reach the battlefield in time to influence combat outcomes. Airborne units especially needed weapons that could be dropped with assault troops and employed immediately upon landing without waiting for heavy equipment or specialized crews. Production considerations added another layer of complexity to the decision matrix. The T-19 required specialized manufacturing facilities and materials that were already committed to existing artillery programs. The T-15 could be produced using modified small arms manufacturing techniques, potentially allowing faster scaling if combat demand exceeded initial projections. But there was no American factory space available for either weapon, meaning production would need to be contracted overseas regardless of which design received approval. By December, unofficial word was circulating that the T-15 would receive limited production, authorization for field testing, but full-scale deployment remained dependent on combat performance that had yet to be demonstrated under battlefield conditions. By February 1945, the T-15 had become the M18, but the weapon existed more on paper than in combat units. Production orders called for 2,000 weapons and 800,000 rounds of 4 different ammunition types. Yet American factories remained committed to existing programs that consumed every available manufacturing slot. The solution came from an unexpected source. Dominion Arsenal in Quebec, Canada had excess capacity and specialized expertise in precision munitions manufacturing. Canadian engineers studied the perforated cartridge case specifications with the methodical attention that the design demanded, knowing that even minor variations in hole, diameter, or plastic lining thickness could transform a precision weapon into a crew-killing malfunction. Major General William Bud Miley received word of the M18's existence in early March while planning Operation Varsity, the largest single-day airborne assault in military history. His 17th Airborne Division had earned brutal experience during the Battle of the Bulge, where his troops had fought as ground infantry rather than making their intended combat jump. The upcoming Rhine crossing represented their first opportunity to prove that airborne forces could seize and hold critical objectives behind enemy lines. But German defenders had turned the approaches to Wesel into a maze of concrete bunkers, machine gun nests, and anti-tank positions that conventional infantry weapons couldn't neutralize at safe ranges. The tactical problem was becoming desperate as intelligence reports revealed the extent of German fortifications. Concrete bunkers with steel-reinforced firing ports dominated every approach to the airborne landing zones. Machine gun positions were sited with overlapping fields of fire that would massacre paratroopers before they could organize effective counterattacks. Standard doctrine called for massive artillery preparation followed by armor support, but airborne units would be fighting alone for at least 6 hours before ground forces could link up with them. Those 6 hours would determine whether Operation Varsity succeeded or became another costly airborne disaster. Miley's operations officer spread aerial reconnaissance photographs across the briefing table, each image revealing new defensive positions that seemed designed specifically to defeat airborne assault. German engineers had learned from previous Allied operations, positioning their strong points at ranges that neutralized bazookas while remaining immune to accurate mortar fire. The 200-yard gap between effective American weapons range and German defensive positions had become a killing field where entire companies could be destroyed while attempting to close with enemy positions. "We need something that can reach out and touch these bunkers from 400 yards, Miley told his staff, knowing that conventional solutions didn't exist. Heavy weapons companies carried mortars and machine guns, but mortars required indirect fire with forward observers who would be among the first casualties in any contested landing. The new M18 promised artillery-level firepower in a package that 2 paratroopers could carry, but Miley had seen too many wonder weapons fail under combat conditions to trust specifications without seeing results. The first 50 M18s arrived from Canadian factories on March 10th, barely 2 weeks before Operation Varsity's scheduled launch date. Each weapon came packed in individual shipping crates alongside ammunition loads that revealed the weapon's versatility. M307 heat rounds carried shaped charges designed to penetrate 3 inches of armor or concrete. M306 high-explosive rounds delivered devastating bunker-busting capability. M308 white phosphorus rounds could clear trenches and wooded areas with chemical fire that forced defenders to abandon protected positions. Each ammunition type required different tactical applications, meaning crews needed intensive training on target selection and engagement procedures. Staff Sergeant Mike Chen had survived Sicily, Italy, and the Bulge by maintaining healthy skepticism toward any equipment that hadn't proven itself in combat. But the M18 specifications intrigued him despite his reservations. At 44.4 pounds, the weapon weighed less than a water-cooled machine gun, but promised to deliver firepower that could eliminate targets previously requiring artillery support. The ammunition worried him more than the weapon itself. 5.3-pound shells packed enough explosive to demolish buildings, but they also created backblast zones that extended 50 feet behind the firing position. Training began immediately with weapons that still carried factory cosmoline and instruction manuals, written by engineers who had never fired the weapon under combat conditions. Chen's squad practiced assembly procedures until they could set up the M18 in under 3 minutes, but theoretical knowledge felt inadequate when preparing for combat. Jumps into defended territory. The weapon could fire from 3 different positions: shoulder-fired for maximum mobility, bipod-mounted for improved accuracy, or tripod-mounted using modified M1917 machine gun mounts for maximum stability and precision. The tripod configuration proved most effective for the bunker-busting missions that dominated Operation Varsity planning. Mounted on the old water-cooled Browning tripod, the M18 could engage targets with rifle-like precision at maximum effective range. But the tripod added 52 pounds to the total system weight, meaning each M18 team would carry over 100 pounds of equipment, plus personal weapons and gear. Chen calculated ammunition loads obsessively. Standard issue called for 12 rounds per weapon, packed 4 shells per 40-pound wooden crate, but combat experience suggested that sustained engagements would consume ammunition faster than peacetime planners. Anticipated ammunition variety created tactical complexity that traditional weapons didn't demand. Heat rounds were designed for bunkers and fortified positions, but would overpenetrate personnel targets, wasting explosive potential on individual soldiers. High-explosive rounds delivered maximum fragmentation against troops in the open, but lacked the armor-penetrating capability needed against concrete emplacements. White phosphorus rounds could force defenders out of covered positions, but created persistent chemical hazards that affected friendly troops if wind conditions shifted unexpectedly. Target identification became critical as crews learned to match ammunition types with tactical situations. German defensive positions varied from reinforced concrete bunkers requiring heat rounds to machine gun nests in wooden structures that high-explosive rounds could destroy completely. Misidentifying targets meant either wasting precious ammunition or failing to achieve the destruction necessary to eliminate threats. Combat conditions would allow no time for careful target analysis, meaning crews needed instinctive recognition of which ammunition type would prove most effective against specific defensive positions. The backblast danger zone created tactical complications that training could address but never completely eliminate. 50 feet of clear space behind the weapon meant that crews couldn't fire from covered positions that offered protection from enemy observation and return fire. Open firing positions made M18 teams vulnerable to sniper fire and artillery, but attempting to fire from covered positions would injure or kill crew members with misdirected explosive gases. Chen's squad practiced rapid displacement techniques, knowing that revealing their position with the first shot
meant they would need to move immediately to avoid concentrated enemy.
Response March 23rd arrived with weather conditions that threatened to cancel Operation Varsity entirely, but Allied commanders decided that further delays would allow German defenders more time to strengthen their positions. 17,000 paratroopers would jump into heavily defended territory, carrying experimental weapons that had never been tested under combat conditions, betting their lives on engineering calculations that promised pocket artillery for infantry units that had never possessed such firepower. Dawn on March 24, 1945, revealed the Rhine Valley shrouded in morning mist that would either conceal the largest single-day airborne operation in history or trap 17,000 paratroopers in a killing field designed specifically to defeat their tactics. British ground forces had crossed the river under cover of darkness near Wesel, establishing precarious footholds on the eastern bank, while German artillery hammered their positions with methodical precision. By 10 o'clock in the morning, 1500, Allied transport aircraft would deliver the 17th and 6th Airborne Divisions into heavily fortified territory, where concrete bunkers and machine gun nests waited in positions that had been surveyed, registered, and prepared for exactly this moment. Staff Sergeant Chen checked his M18 one final time as his C-46 Commando droned eastward over Allied lines, the weapon's unfamiliar weight adding to equipment loads that already strained paratrooper mobility. 12 shells packed in 3 ammunition bags represented firepower that his squad had never possessed, but also responsibility that kept him awake during the 2-hour flight to target. Each heat round could eliminate a concrete bunker, but only if his crew could set up the weapon, identify targets accurately, and engage them before German defenders concentrated return fire on their exposed position. The drop zone stretched below like a dark carpet punctuated by open fields that would become Drop Zones X, I, and Z intelligence photographs had revealed the tactical nightmare awaiting airborne forces. Machine gun positions sighted to create crossfire zones over every landing area, mortar positions registered on likely assembly points, and concrete bunkers positioned to dominate approaches from any direction. German defenders had studied Allied airborne tactics for 3 years, learning from Sicily, Normandy, and Market Garden to create defensive systems specifically designed to massacre paratroopers before they could organize effective resistance. The tactical revolution was becoming apparent to German prisoners who described their shock at watching bunkers that had taken weeks to construct disappear under single hits from weapons they had never encountered. German defensive doctrine had been based on the assumption that American infantry lacked the firepower to eliminate concrete fortifications without calling for massive artillery preparation that revealed attack timing and directions. The M18 had rendered those assumptions obsolete by giving 2-man teams the capability to destroy any defensive position they could see in. Accurately ranged combat reports from other M18 crews confirmed the weapon's versatility across different tactical situations. High explosive rounds had proven devastatingly effective against personnel in the open, delivering fragmentation patterns that cleared trenches and defensive positions with single shots. White phosphorus rounds had forced German defenders out of covered positions where they became vulnerable to small arms fire, while the chemical burning effect had denied terrain to enemy forces attempting to establish new defensive lines. But the weapon's most significant impact was psychological, rather than purely destructive. German commanders had positioned their defensive systems based on detailed understanding of American infantry capabilities, creating killing fields at ranges where bazookas were ineffective, and mortar fire required forward observers who would be among the first casualties in any assault. The sudden appearance of weapons that could accurately engage targets at 450 yards had disrupted defensive calculations that had taken months of preparation to perfect. Intelligence reports began documenting German tactical changes that reflected growing awareness of American firepower capabilities they had never encountered. Defensive positions were being abandoned when they came under M18 fire, even if the initial shots missed their targets. German machine gun crews were avoiding positions that offered good fields of fire, but exposed them to direct fire from ranges they had considered safe. The psychological effect of watching concrete bunkers disintegrate under single hits was forcing tactical modifications that reduced German defensive effectiveness across entire sectors. The weapon's combat debut had also revealed limitations that training exercises had failed to identify. Ammunition consumption exceeded peacetime projections when crews engaged multiple targets in rapid succession, and resupply became critical during sustained engagements. The 50-foot backblast danger zone had forced tactical compromises that exposed crews to enemy observation and return fire, though German counter-battery capabilities had proven less effective than anticipated. Most significantly, the weapon's effectiveness depended entirely on crew, training and target identification, skills that required experience levels that new replacement personnel might not possess. Production reports from Dominion Arsenal in Quebec indicated that manufacturing could be scaled to meet increased demand, but delivery timelines remained constrained by shipping capacity and quality control requirements. Each M18 required precision manufacturing that could not be rushed without compromising the tolerances that made the perforated cartridge case system function reliably. Canadian engineers had mastered the production techniques, but expanding manufacturing to American facilities would require months of tooling and training that combat units could not afford to wait for. By June 9, 1945, M18s had reached Pacific Theater units fighting on Okinawa, where Japanese defensive tactics had created tactical problems that perfectly matched the weapon's capabilities. Japanese fortifications carved into coral and concrete had proven nearly impervious to conventional infantry. Weapons requiring massive artillery, preparation that alerted defenders to impending attacks, and often failed to eliminate hidden positions. The M18's precision and portability allowed infantry units to eliminate specific bunkers and cave positions with surgical strikes that preserved the element of surprise. Combat reports from Okinawa confirmed that the weapon's effectiveness against fortified positions exceeded even the optimistic projections that had justified its development. Japanese defensive positions that had withstood sustained bombardment by 155mm artillery were being eliminated by single heat rounds fired by two-man crews who could approach targets under cover and engage them from concealed positions. The tactical flexibility was revolutionary. Infantry units no longer needed to call for artillery support that revealed their positions and timing to enemy observers. Korean war authorization tables reflected the M18's transition from experimental weapon to standard infantry equipment, with each rifle company allocated 3 weapons and appropriate ammunition loads. The designation had evolved from T-15 to M18 to M20 as manufacturing improvements and tactical modifications were incorporated. But the weapon's fundamental concept remained unchanged, giving infantry units artillery-level firepower in a package that could be carried and employed by conventional foot soldiers. Edward Kroger received reports of the weapon's combat success while working on post-war development projects that seemed mundane compared to the life-and-death urgency that had driven the M18's creation. Letters from combat veterans described how the weapon had saved lives by eliminating threats that would have required sustained assault by multiple infantry companies, validating engineering decisions that had been dismissed as dangerously impractical by conventional military wisdom. The final vindication came in casualty statistics that showed dramatically reduced infantry losses when units were equipped with M18s compared to similar operations using conventional weapons. Soldiers who had initially viewed the weapon with skepticism because of its backblast characteristics had become its strongest advocates after experiencing its devastating effectiveness against targets that had previously been untouchable by infantry weapons. By war's end, over 2,000 M18s had been produced and deployed to combat units that used them more against fortified positions than against the tanks they had originally been designed to engage, proving that innovation often finds applications that exceed the vision of its creators. 10 o'clock arrived with flak bursts that turned the morning sky into a constellation of black smoke puffs, each explosion marking German attempts to destroy transport aircraft before they could deliver their human cargo. Chen felt his C-46 shudder as shrapnel punctured the fuselage, but the pilot maintained course. toward Drop Zone X with the grim determination of air crews who understood that their mission success was measured by how many paratroopers reached the ground alive rather than how many aircraft returned to base. The jump itself felt routine despite the circumstances. 20 seconds of controlled fall, followed by parachute opening shock and the familiar sensation of drifting toward Earth while completely vulnerable to enemy fire. But routine ended the moment Chen's boots hit German soil, and automatic weapons fire began raking the drop zone from concealed positions that intelligence had failed to identify. Machine gun tracers created deadly patterns of red light that cut down paratroopers before they could shed their parachutes, while mortar rounds began falling with the precision that came from months of defensive preparation. Chen's squad scattered toward the nearest cover, a drainage ditch that offered concealment from observation but no protection from plunging fire. Around them, other 17th Airborne units were attempting to organize cohesive resistance while under fire from positions they couldn't see, let alone engage effectively. Standard infantry weapons could identify muzzle flashes, but lacked the range and precision needed to eliminate fortified positions that had been designed to survive conventional assault. The first M18 target revealed itself when a concrete bunker began methodically sweeping the drop zone with machine gun fire, each burst cutting down paratroopers who were attempting to reach assembly points. Chen estimated the range at 400 yards, well beyond bazooka effectiveness, but perfect for the untested weapon he carried. His assistant gunner, Private Rodriguez, had already assembled the M1917 tripod with movements made automatic by weeks of intensive training, knowing that setup speed would determine whether they could engage targets before German observers directed counterfire on their position. Loading the first heat round required deliberate care despite the chaos surrounding them. The M307 shell weighed 5.3 pounds and carried a shaped charge designed to penetrate 3 inches of reinforced concrete, but only if fired accurately. From a stable platform with proper range estimation, Chen aligned the weapon sights on the bunker's firing port, knowing that missing meant wasting irreplaceable ammunition, while his fellow paratroopers continued dying under machine gun fire they couldn't suppress. The trigger squeeze felt identical to countless training rounds, but the consequences were entirely different. The M18's muzzle blast created a distinctive crack that announced precision firepower to anyone within hearing distance, while gas venting through 400 perforated holes produced the controlled steam explosion sound that had become the weapon's signature. 50 feet behind their position, backblast scorched vegetation and filled the air with superheated gases that would have killed anyone caught in the danger zone. 400 yards away, the heat round struck the bunker's firing port with surgical precision and detonated inside the concrete structure. The shaped charge's copper liner formed a molten jet that penetrated 3 inches of reinforced concrete as if it were plywood, then expanded inside the bunker to create devastating overpressure that killed the entire machine gun crew instantly. Secondary explosions followed as stored ammunition cooked off, transforming a deadly strongpoint into a smoking crater that no longer threatened airborne forces attempting to organize defensive positions. Chen watched through his sights as the bunker disintegrated, hardly believing that a weapon he could carry had just delivered destruction that previously required divisional artillery support. But there was no time for amazement. German defenders were already adjusting fire to engage the M18 position, and muzzle flashes from other concealed positions indicated multiple targets that needed immediate attention. Rodriguez had already loaded a second heat round, understanding that revealing their position meant they would need to eliminate multiple threats quickly or displace to avoid concentrated retaliation. The second target was a machine gun nest constructed inside a reinforced farmhouse 350 yards to the north, its position marked by tracers that were decimating paratroopers attempting to advance across open ground. Chen adjusted his aim and fired again, watching the heat round punch through the building's stone walls and detonate inside with devastating effect. The machine gun fire stopped immediately, replaced by secondary explosions that indicated the building had contained substantial ammunition stocks. Within 15 minutes, Chen's squad had eliminated 4 separate German positions that had been pinning down entire companies of paratroopers. Each engagement demonstrated capabilities that no infantry weapon had ever possessed. artillery-level destruction delivered with rifle-like precision by a two-man crew using portable equipment. German defenders began avoiding positions that had been targeted by M18 fire, understanding that concrete bunkers, which had seemed impregnable to conventional infantry weapons, offered no protection against shaped charges that could penetrate any fortification they had. Constructed at other M18 teams across the drop zone were achieving similar results, systematically eliminating strongpoints that had been positioned to create interlocking fields of fire. The tactical advantage was shifting in ways that German defensive planners had never anticipated, as weapons they had never encountered began destroying positions that had taken months to construct and fortify. For the first time in airborne warfare, infantry units possessed immediate fire support that could neutralize prepared defenses without calling for artillery strikes that took 30 minutes to coordinate and announce friendly positions to every enemy observer within miles. By noon, the 17th Airborne Division had secured objectives that mission planners had expected to take 6 hours of sustained combat to achieve. By 1800 hours on March 24th, the 17th Airborne Division had achieved objectives that operational planners had allocated 2 days to complete, but the cost had been measured in casualties that reflected the brutal reality of airborne warfare. 1,300 American paratroopers had been killed or wounded during Operation Varsity. Yet, they had captured over 2,000 German prisoners and eliminated defensive positions that could have delayed the Rhine crossing for weeks. The M18 had proven itself under the most demanding combat conditions possible, but its success was being measured in tactical reports that would determine whether Kroger and Muser's dangerous innovation would survive the transition from experimental weapon to standard infantry equipment. Major General Miley walked through positions that his paratroopers had seized with firepower that previous airborne operations had never possessed, examining concrete bunkers that showed the distinctive penetration patterns of heat rounds fired at precise ranges. Each destroyed strongpoint represented enemy resistance that would have required sustained assault by multiple companies using conventional weapons. Yet M18 crews had eliminated them with single accurately placed shots that left no doubt about the weapons' devastating effectiveness against fortified positions. Staff Sergeant Chen's after-action report documented 12 separate engagements where his M18 had destroyed targets that were beyond the effective range of any other infantry weapon. Machine gun nests at 400 yards, concrete bunkers with steel-reinforced firing ports, anti-tank gun positions that had been sited to dominate approach routes, all eliminated with shaped charges that penetrated fortifications as if they were constructed from cardboard rather than reinforced concrete. The weapon's rifled barrel had delivered accuracy that matched dedicated anti-tank guns, while its portability had allowed rapid displacement between firing positions.